Hi, and welcome to API Craft. In this session, this first part of a three-part series on API design, we're going to be talking about how to model your API. So, firstly, who are we? So, the API Craft group that I coordinate cuts across Singapore, Indonesia, Thailand, and also with Prasant Putamvidu. We cover the API Craft and all about APIs groups in India. So we're about 2,000 people in this community across these countries, mostly technical people, but also people who are interested in the business of APIs. You can find out more about API Craft at apicraft.co, where we also have recordings of our previous meetups. And of course, please connect with me on LinkedIn or with Prasant. I'm based in Singapore, whereas Prasant is based in Bangalore. So, a bit about me. I specialize in API strategy and implementation. I'm also the organizer of the API Days Singapore and Jakarta conferences, and we'll talk about that in a moment. The API Craft meetup groups I coordinate across Singapore, Indonesia, and Thailand. Prasant is based in Bangalore, as I mentioned, and he organizes the API Craft Bengaluru and All About APIs meetup groups, and is the key person organizing the very first API Days India conference this year. So a bit about this series. Today we're talking about how to model your API. The next in the series is on the 28th of January, and that will be about defining your Open API specification. And then on the 18th of February, we'll be covering how you document your API. And all of this leads up to the API Days Jakarta conference on the 24th of February. The evening before that, we're holding a special API design masterclass with the author Mike Amundsen. Just so you understand, this meetup, as well as the other two in the series, defining your Open API spec and documenting your API, are free and online. And the API Days conference in Jakarta is also free and online, but the masterclass with Mike is a paid activity, and we'll talk about that a little bit more later. So what we're going to cover in this session, we're going to talk about the purpose of an API, some of the design principles, what is in a model, and what a model is and what it isn't. And also we'll look at one specific type of model, the web sequence diagram. And then we'll talk about what comes next in the rest of the series. So some of the inspirations for this session, this book, API Product Management by Andrea Zulian and Amancio Buza. It's very good at the API strategy level, figuring out what value an API will provide to a user of that API, and how you come to that conclusion and how you develop that from there. Another one is The Design of Web APIs by Arnaud Leray. Arnaud does a really good job of translating design thinking principles into APIs. So particularly the thinking of Donald Norman, the author of The Design of Everyday Things. And the other key inspiration for this session is Mike Amundsen's latest book, Design and Build Great Web APIs. And Mike, as I mentioned, has written a number of books on the topic. He is a leader in the field, and he will be running the masterclass as part of the API Days Jakarta conference. So firstly, what is an API? To be honest, I think anybody who's come to this session already knows what an API is, but we all need to explain this to other people. So I give the explanation that I usually use about what an API is. So an API is a format for exchanging information between systems, usually a requester and a provider. A very simple example of this is the Google Maps API. Everybody's used probably Google Maps on their phone, but Google have extended this by publishing it as an API. So if you're a developer and you want to show a location or a route to your users, you know nothing about mapping, you don't need to, because if you send a message like this, it's not exactly a human readable message, but if your system can send a request like this to Google, then Google's going to send you back an image like this. So, and there are more complicated aspects to the Google Maps API, but this simple static map is readily available through the Google Maps API, and it simplifies how you present information to your users, because with a few simple parameters that you send to Google, you get very rich information in response. So we'll talk a little bit about what an API is for. Your API, you have to think about who's going to use it, what do they want, and what will the API give them. So there are a number of models for thinking this through. Quite a useful one is the value proposition. The value proposition canvas. It was developed by Alexander Osterwalder of Strategizer. This chart really needs to be read from right to left. So when you think about the customer first, you think about the jobs that the things that make their life easier, or relieve pain. They provide a gain, that increased revenue, or lowered complexity, or lower risk, or less effort, and that comes down to the customer jobs. So on the left hand side, if you're looking to provide products or services to this person, you should be thinking about, well, is this product or service a gain creator, or is it a pain reliever? Now, Andrea and Amancio, in their book API Product Management, they modify this slightly, so you can still see that you've got the gains, pains, and customer jobs, and the value proposition on the left hand side of the page. But what Amancio and Andrea talk about is this interface. This API is not really an application programming interface. Is a value proposition interface. It is what translates the product or service into a gain or a pain reliever for the customer. So to break this down a step further, to actually think about how you relate what an API does to people, you can do this in the form of an API story. This is very similar to a user story. As a person, I want to do such an activity in order to achieve some other purpose. So an API type of story could be along the lines of, I'm a distribution partner of this company, and I want to create a new customer record in my partner's system, so that I can accept new orders from that customer. So framing it this way helps you to think about the user of your API first, your API, and the the user of an API is often a developer, but it's a developer who has a purpose that they want to fulfill. A good way of preparing for this conversation with the user of the organization, user of the API, is to think about consumer-driven contracts. So an API is essentially the contract between the requester of a resource and the provider of a resource. And the advantage of having that API, that contract, is that each side of that transaction can create their own, develop their own systems in whatever language they want, because the API itself is language agnostic, and they can do it independently of one another. So as long as you've defined this contract, then the client development team, the requesting that's going to request the API, can go and develop their own code even before there is a back end to support it, because it's going to work to this contract. So the sequence of going through this is the producer will publish a blueprint for what the API is going to do. Ideally you would agree that with the consumers of the API, and the consumers use the blueprint to build their contract, and they test only the endpoints or properties that they're going to use. But also with that, you need to continuously test the contracts against the API. As an API as a piece of software, it has a life also, and the software that serves the resource, provides the resource that the API exposes, also evolves. So there's a need for continuous testing of these contracts against the API. So when you're designing the API, it's good to think about how people will use the API, how you make it life easier for the business people who made a decision to use your API, and also the developers who have to write the code that's going to communicate with it. Now, the leading thinking in design, a very good source is Donald Norman's The Design of Everyday Things. And as I said, Anna Luray has done a good job of translating those concepts into the design of APIs. One of the key aspects of design is thinking about what is the affordance. Is it clear what it's for? So you see this example of two types of displays on a door, one marked push, the other marked pull. Now, actually, these are labeled push and pull, but if that writing wasn't there, or if you're dealing with people who don't speak English, or the language that writing is, then it's better to make the purpose of that component clear, regardless of whether there is any writing on it. So you can see, when you see a flat plate, you're probably not going to try and pull that. You're probably going to try and push it. When you see that U-shaped bar, you're probably going to try and pull it. And when you provide those sorts of signals, those two plates are both functional in their way, but their meaning is also clear. And that's really what you want to try and convey when you build an API, as much as any other thing. Another good source of design principles you can find on the Interaction Design Foundation website. They talk mainly about user experience, but the same principles apply to APIs as well. So one of the things that Donald Norman introduces is the concept of the action lifecycle. When somebody wants to achieve something, they set themselves a goal, and then they figure out a plan for how they're going to achieve that goal. They specify some actions, then they perform those actions. After they've done those things, that what Norman calls the bridge of execution, then they start to evaluate. They perceive what has happened from that action. They interpret, has it achieved, what impact has that had, and then compare, has that achieved my goal yet? And if not, then you're going to go through that cycle again of planning a new action, specifying and performing it, and then perceiving and checking to see if that's achieved their purpose. So in Mike Amundsen's book, he reduces that to a what he calls the API sequence, where a requester is going to send a request, it's going to get a response from the API, then it's going to compare, has that achieved it, and then wait for the next step. So some example APIs that we might try to build. So one of them, it could be customer onboarding. We want to register a new customer. There may be lots of different steps to perform. It's easier for a system that's requesting that to call an API that handles all those sorts of functions. Another example could be accessing some data, so accessing a resource, data like stock prices or customer information. Another API might be to update information. So you need to send information to update the records for a customer or an account. And another one could be to initiate a transaction. So let's look at some of what goes on in these. We need to think about when we create a model for how this happens. We'll have a title and a simple description. We'll have some certain data and the properties of that data that are going to be concerned in this activity, in this transaction. We're going to have different elements that pertains to, and we're going to have actions that need to be taken by the different systems, and the parameters, that is, what are the details of the actions that need to be taken place. So in the model, but in developing a model, we don't want to go straight to code, because firstly, not all your stakeholders are coders. There may be a developer who has to write a request to make that request of the API, but that developer won't even start to go through that process until you've demonstrated that it's going to provide them with some value. And there may even be a business person or some other stakeholder who perceives that there is some value from your product or service, and you need to provide them with information about that before you get down to the specification. So, and you do that by creating a model. A model is a representation of a thing. It's not the thing itself. Just like a map, it has lots of information about a location, but it's not the location itself. And in fact, if you had a 1-to-1 scale map, that would not be useful to anyone at all, because it's exactly the same complexity as the thing itself. So you need to simplify some things and represent the key information contained in that, not all of the detail. To some extent, you're hiding some information. It has to be described in a form that the readers can understand. So if you're dealing with a a business stakeholder who needs to recognize the value in the product or service, then you need to be talking in terms that they understand first. If you're talking to more of a technical person, a process designer, then you need to be talking in process terms. What a model is not, it should not be language specific. It should not specify, I'm going to use Java, I'm going to use C or another language. It should be as agnostic as possible. And for that reason, it's not really a code ready definition. It is an intermediate step before you get to the coding. So let's look at the customer onboarding example that we mentioned earlier. The activities that you need to take when you onboard a customer is, firstly, you want to verify the customer's identity. You want to know who they are. If they're applying for a product, if they're going to a bank and applying for a loan, or even to simply open an account, then you need to understand exactly who you're dealing with, and that applies whether it's an individual or a company. Then you need to do some sort of background check on that person. If it's someone applying for a loan, then you want to do some credit check of that person, and it may be with a third party, with another agency. You then need to go, assuming that's successful, then you actually need to go into the system of record, the account keeping system, and create a new customer account. And you need to create the details for you and the customer to be able to manage that account, and provide a message indicating that has been set up successfully. So here is an example of a web sequence diagram that serves as a model for this type of interaction. You can see and this is not the only way of describing it, but the advantage of a web sequence diagram is it starts to break down the activities and the information that's passed between the different parties into components, and then those the people who read this can take actions to create the steps, the details, the information that's needed for that to happen. So we talked about the customer wanting to register with perhaps a client application, and it might be the company's own client application, or it might be a partner's client application. To register for a new account, the customer makes that request and then gets challenged to provide some form of identity, whether it's an email address, or it may be more detailed identity information. Certainly in relation to a bank account or insurance policy, you need much stronger identity information. So the customer provides that back to the client. The client forwards that on to a server that's managing this process through the API. So it's essentially an onboarding request. And if this involves a background check with a third-party agency, then information would be requested of the agency. Information is sent, and a response comes back from that. And then the next step would be to create the account in the account system. So you're going to send information related to the account system, and then get a response back from that. And if all that is successful, then the account details get passed back to the client application, which then passes that back to the customer. So this particular drawing was drawn in web sequence diagrams, funnily enough, from a website called websequencediagrams.com. You can create your own free user account on this site to create these sorts of diagrams. We'll look at an example in a moment of how to do that. Other Other sorts of use cases, we mentioned data access. If you want to access data, then there are several steps that you will need to go through in order to achieve that. Again, you want to authenticate the user. You want to authorize that the user has access to the resource. If there is a key or token to request the actual resource, then that needs to be passed, and then the user will pass that on to the resource owner to actually collect the resource. Similarly, with data update example, authenticating the customer again, providing new information, ensuring that the account system has been updated, and then a confirmation back to that. The service might be also a transaction, for example, initiating a payment. So you want to go through an authentication step. You want to select who you're going to pay, select things like the payment amount and currency, and then authorize the transaction and then initiate payment. So all of those things are related, involve steps, and you want to lay out those sorts of steps in the process and ensure that you've defined what the API is going to do to facilitate that, the information that's going to be passed back and forth through the API. So here is an example of the onboarding API that Mike Amundsen describes in his book. I can actually show you this website a little more clearly. Let me step back to here. The customer onboarding API is actually what I showed you earlier. It has this chart, but this chart is actually built from a set of instructions that we put down the left-hand side. So if we use, say, another example, I want to create a new one. I go to create a new file, and I get confronted with this example here. But if I say I want to create a new one called data access API, I can modify this slightly on the left hand side by indicating the players involved here. So this would be a user connecting with a client, and it's going to do an authentication request. Then I don't actually need this note. This is an option that I can put here, but I'm going to remove that. The client is going to send information back to the user with maybe a challenge, and so this updates. Actually, I'm going to simplify this by removing those other boxes that we're not seeing here. So in here, we're going to the user is going to reply with to the client. I'm going to provide more information, and I'm going to say that there's a step in here. So we're going to take an action here. We're going to user info. It provides the user information. The client is then going to provide some information to the server to authenticate the user. right? So we're building this up as we go, and the server is going to take an action to back to the client to say authenticated okay. Actually, if this is simply a message, an OK message, then we can simplify that a little further by making it into a dash line, and then we can continue in these steps. So this is a very useful tool to create a consistent looking model of an API, and we can when we create that level of consistency while still demonstrating the types of actions that are being taken and the information being passed between these different players, then it becomes a lot clearer to the users, to the stakeholders in the production and use of this API, what is going to happen here. So what we looked at here, what happens from here once you have a model that that all the stakeholders are comfortable with, well, then you need to translate that into a specification that people can build code to. And what we're going to look at in the next meetup is specifically the Open API specification, because it's really the standard for how you build a REST API. For event-driven type of interactions, you may use the async API specification. REST API isn't the only API style. You may also decide to use a GraphQL or a remote procedure call type of style of API. But notice that the model that we created in the web sequence diagram is agnostic to all of those. So it's something that many people will be able to understand, technical or non-technical. Provides more information so that people can actually think about the data that is being transferred between the different players in this transaction. So the next step from here is to go to a specification, and that's the topic for the next session. So what we covered today, we translated. What we covered is we talked about the API value proposition, design thinking principles, what a model is and is not, and we gave some examples of using a web sequence diagram as a model to show how an API is going to work. So what happens next? So this session is about modeling your API. The next session on the 28th of January is we're going to show how to define your Open API specification based on a model. And then on the 18th of February, we're going to cover how you document an API for all types of users, not just the developers who are writing code. And then, as I mentioned earlier, the API Days Jakarta conference is on the 24th of February, and the evening before that, there is an opportunity to get some really good hints on improving your API design with Mike Amundsen, who's a leader in this field. So the next meetup, it's now possible to register for this. We encourage you to join us for that. And just a quick indication of the upcoming API Days conferences. In Jakarta on the 24th of February, the Helsinki conference on the 15th and 16th of March. Now there is some overlap between the Helsinki time zone and the Asia Pacific time zone, so there's an opportunity to join that also. The API Days Singapore conference on the 21st, 22nd of April, and the API Days India conference on the 20th of May. You can find out more about that at apidays.co. about all of those conferences. And of course, if you want to speak, then please respond to the call for proposals, and let us know that that you're interested in speaking. So thank you very much for joining me for this discussion about modeling your APIs, and I look forward to seeing you on the 28th to discuss defining your Open API spec. Thank you.